Hi, in this demo, I'm going to show how to run a GIS data pipeline on Kubernetes using Tekton. So before I start this demo, let me give you a brief overview of what I'm trying to do. So here, what I'm going to do is to get a set of images, that is RGB color images of a landscape, and convert that into a 2D map and view it and serve it through a web browser. So to do that, I'm going to use a tool called OpenDroneMap. OpenDroneMap is a photogrammetry software. Photogrammetry is the technique by which we can extract geometric information from two-dimensional images or videos. So what this means is that if you can collect a set of images of a landscape using a UAV or using a satellite, we can use photogrammetry to generate the map, like a Google map. So there are so many different software libraries which you can use to do photogrammetry. So OpenDroneMap is one which is free and open source. So I'm going to use that. So this is the OpenDroneMap GitHub project. They have provided a container image. So I'm going to use that to run a task. They have also provided a set of data sets. So this is a sample data set of a park. And this is the expected output, and so the data set is a collection of images collected using a drone or a balloon or a satellite. So each of these pieces are individual images from different parts of the park. So I'm going to use a forked version of this data set. So I'm going to use this one, and then it will have it's almost the same, but this one has a subset of images. I'm also going to use Tekton pipelines to ask the task/pipeline framework. So this is a project under CD Foundation. You can find the repository here, and I'm going to use the latest release 10.1. So as we can see in this demo, I'm going to use an external storage as my data source, and I'm going to use OpenDroneMap to convert the images into 2D map, and I'm going to use a result server to publish my results, and it's going to run on Kubernetes with the help of Tekton pipelines. Yes, photogrammetry is run using OpenDroneMap, and I'm going to use GDAL libraries for map tiling. So map tiling is the process of optimizing the output for viewing on a browser. Tekton pipelines is used as a task and pipeline framework, and Kubernetes is the platform. Okay, so this is the structure of this demo. So the external storage will be represented using a Tekton artifact called Tekton component called pipeline resource. The OpenDroneMap plus the GDAL part will be represented or will work as a Tekton pipeline task, and the result server is a Kubernetes deployment running an Nginx image. And there will be which will provide a web UI to view the results. I'll show you a quick overview of the task. This is how we write a Tekton task. So it's Tekton task is basically a custom resource definition, and this is an instance. So the kind is task. And there are 3 steps in this task. First step is called ODM orthophoto. It just uses the OpenDroneMap ODM image to convert a set of input images, input aerial images into a 2D map. The second stage is a map tile gen step, which you can optimize or slice up the output image into smaller pieces so that it's easier to be viewed on the web UI. And the third step is a tar and store. So basically, we store that output onto the result server. The pipeline resource is what represents the input for this process. So it points to the GitHub repository, Nickel Thomas ODM data acromap, and the branch is Minidata. The result server is a simple Kubernetes deployment. It runs the Nginx image, and it is exposed using a Kubernetes service. I have already installed the Tekton pipelines on my on my cluster. So I can, if I do kubectl sorry. So Tekton pipelines is already running on my cluster. So next, I'll be also using a CLI tool called TKN. So TKN is a very convenient CLI which can be used to interact with Tekton pipelines components. I can use kubectl to work with Tekton pipelines, but TKN offers a lot of convenient options. So I can list Tekton tasks using TKN task ls. And that auto photo with tiling task is already added to my cluster. And I can also check for TKN. Can see that I have also set up my input data source. And now I can I can run the task. You can see that it has started running. There is a new task run. I can collect logs from that task. So now I can see that the input data source has been downloaded, and now it's being converted into the 2D map. It will take a minute. In that time, let me go and talk about why this is very useful and what are the advantages. The advantage here is that the pipeline task or the pipeline or the Tekton pipeline task can be expanded or can be extended. And that means we can add more steps into the task, or we can combine multiple tasks and create a pipeline. So we can add more steps like pre-processing of input or post-processing of output, etc. And it's very convenient and easy. And in this case, Kubernetes will take care of scheduling of tasks or nodes. I have worked with this before on Docker and Docker Swarm. I could get some results, but it was more involved. I know the scheduling was more involved. I had to consciously decide where I want to run my OpenDroneMap pods or containers. With Kubernetes, I can specify my requirements in a task specification. And let's say that I have a task which has heavy GPU or CPU requirement, and then I can let Kubernetes schedule those tasks in a CPU optimized or GPU optimized node. And if I want to run the same pipeline on different data source, I can run them in parallel, and Kubernetes will schedule the task or pipeline with respect to the availability of resources. Tasks and pipelines are extendable and customizable, and pipelines can be shared between teams and users. So I can write a pipeline, and if there are other people who are interested in using that, I can share it with them, and they can extend the pipeline and they can use it for their data sets. Tasks and pipelines are Kubernetes custom resources. So what this means is that Tekton pipelines is an enhancement on Kubernetes. So basically, it adds a set of CRTs and a controller on Kubernetes. So if you are familiar with Kubernetes, there is very little learning to start working with Tekton pipelines. So you can leverage your Kubernetes knowledge and start working with Tekton pipelines to run your GIS workloads. Let's check the status. Okay, so we can see that the map has been generated, and the map tile were also generated, and then it was pushed to the result server. So if I go check my Nginx page here, so this is the page served from the Nginx deployment, and if I reload, I can see one more entry. If I go there, You can see that the map has been created and being loaded. Okay, thank you.